2 of 5, 5. Today we're going to focus on composite functions, but just as a quick review, we're going to do a combining of functions where we're dividing these two functions. So go ahead and try this, and I'll stop the video and then explain it when you guys get back. Out like this, and then you think, well, maybe there's a way I can factor that out. And sure enough, what are some factors of 6? 3 and 2, and one of them would have to be negative. It'd have to be the biggest one. Isn't that handy? Because that's the same as the one on top. 2 would be positive. And you can double check. Minus 3 plus 2x, that would give me a negative x. Yep. And multiply these, I get the negative 6. So these cancel out, and that the rule then, remember we call this the rule, is 1 over x plus 2. However, the domain would have some restrictions based on the denominator right here. So that can never be 0. So the domain is, it's all the real numbers except x cannot be 3, and x cannot be negative 2. So I guess technically you would accept x being 3 and x being negative 2, but you just need to know that x cannot be 3 and x cannot be. Maybe this shouldn't be written like that. All right, so today we're going to talk about composite functions. And this is kind of interesting. If you remember what I was showing you earlier, when you take a function, whatever this function is, let's see. Let's do the g first. So this is taking whatever input and adding 1 to it. So I take my input and add 1 to it, and then I take my output, whatever that is, and now that becomes my new input for this one, which is x squared. So if I take my number here, this written like this, it means I take 3 and put it into here. So I'll put 3 in there. And what would come out? Well, I just added 1 to it, so 4 would come out. So I need to take 4 and put it into this function, and what would come out of that one? When I square it, I would get 16. So here I add 1 to it, and here I take whatever this is and I square it. So you're applying the rule for g. You always do what's inside the smallest parentheses first, the closest ones inside, and then apply the rule for f to the result. In other words, this is your output of, whatever, in this case, g of x. And then you use the rule on that, the f rule, and then you simplify. All right, so if I wanted to find a whole list of numbers, I could just plug every number in and do this, however, maybe I'm going to do it 100 times, so 100 different numbers. But there is a simpler way. If I have the general rule up here for each one, I can make this composite function. So f of g of x is taking my f of x, whatever that is, I'll do the g. X is now the input, I'll call it x, that probably is not a good way to say it. The input of the function f is the output of this function. So the output of that function is x plus 1, and then f means, f of x plus 1 means I'm doing this to whatever the output of this was. So now I'm going to take that and square it. So I'm going to take the x plus 1 and square it. And the reason I'm doing this is, and I can do that in my head because I've done this so many times, but you can, whatever way you want to use. Now I have a general rule, right? This is the composite function. Now I don't have to, if I have a whole list of numbers, 1 to 100 or whatever, I don't have to put it into g of x and then put it into f of x and then take 2 and put it in there, and then put it in there, and 3 and blah, blah, blah. I can just put it all into this function right here, and it just saves me a little trouble from doing that. And this one I missed a parentheses. Let's try this one. I'll get you started because I think the first couple times you do this, it's a little confusing. And do pay attention to the order. So g of x, or excuse me, g of 2 would mean I would do this first. So that I would get 6, right? That's my output of g of 2. Now I would take the f of 6 and do 6 for the x and subtract the 1. 12 minus 1 is 11. So that gives me one number, right? Now what if I want to just get a general rule so I don't have to do this every single time, put it into both functions? I would take my g of x, which is 3x, and I'm taking the g of x and putting it in for x. So now it's 2 times this thing, the output of this one, minus 1. So that's 6x minus 1. Well, what did I say up here? X was 2. So if I put 2 in here, that 6 times 2 is 12, minus 1 is 11. So perfect, right? I've made it simpler. Now, I don't have to go through a whole bunch of operations each time. I can just do one operation on my number here. All right, this one is a little more complicated because I want to find out if f of g of x is the same thing as g of f of x every single time. We might find out later that there is a situation where that's true, but let's try it here to see if it works on these two particular functions. So I kind of just pick some random functions. So f of g of x. So g of x is 5x plus 3. So that's my output when I perform this g of x on x. This is what I get. Now the output here becomes the input here. So I'm going to square that, multiply it by 4, and then add 3 to it. So this is, it can be written like this too. Circle G. This is the same thing as this. Well, I'd have to do a little, again, I can do that in my head because I've done this enough, but you can make your box, or you could do a squared plus 2 times a times b. Well, a times b is 15x, so 2 times would be 30x. And then b squared would be 9 plus 3. Don't forget your 3. Now I'm going to multiply that out by distributing this. So I get 100. I do not know why it does that. Okay, it's probably my hand. 100x squared plus 120x plus 36 plus 3. And then these are all, you can combine these because those are as simple as it'll get. So that's f of g of x. All right, I want you to try g of f of x and see if you get the same answer. You get the same thing that I did? So this is 20x squared plus 18. Notice this is g of f of x. So I took the output of f of x, which is 4x squared plus 3, and that is now the input to the g of x. So instead of 5x, I do 5, whatever this is, 4x squared plus 3. And then I distribute out, right, and got 20x squared plus 15, and then I combine these and got this. So no, they are not the same. And all you need is, if you're trying to make a rule and say this is true, all you need is one example that shows that it's not. And this is definitely one of those that it's not. So let's try doing these, just writing them out. So you're going to define f of g of x, because you do need practice doing this. Once you get the hang of it, it comes fairly smoothly, but it takes a while sometimes because of the order of things. So I want you to prove again that this is not true, that f of g of x is not the same thing as g of f of x. Check your work and see if you did it this way. So g of x is defined to be 5x minus 2. So now I'm using that instead of x here. So I have to remember I'm squaring that and then multiplying it times 4 and subtracting 5 from it. So this is the important part right here. And when I square that, again, you can use your box method, FOIL, or however you want to do it, or know that this is a squared is 25x squared, and 2 times a times b, negative 2 times 5x is negative 10x, and 2 is negative 20x, and then negative 2 squared is 4. And the biggest thing is you don't want to forget to distribute out this, and then combine the last terms here. I almost forgot that, so that's something you want to try to remember too. So f of x is this right here, the 4x squared minus 5. And I'm using that as my input here. So 5 parentheses, whatever that is, minus 2. And then I distribute out and combine my constants over there. Here is what we started with yesterday, some definitions, and you'll want to make sure you understand these. When we talk about a composite function, we're applying the rule of one function f to the rule of another function g, and it looks like this. That's a composite function. And you remember that the output of g of x, the output of g of x is the input of f of x. So that's important to remember. And then the composition of functions refers to this operation right here. It's just that specific thing that we're doing. We're making the input of the inside function, the output of the inside function, the input of the outside function. I know it sounds challenging. So here's something, though, we hadn't talked about in the previous problems. What about the domain of this composite function? The domain of f of g is the set of all real numbers, x in the domain of g, such that g of x is in the domain of f. Well, that sounds a little confusing, but what you have to remember is the domain of the composition of the intersection, when it's in this order, it deals with the domains of g and f of g, but not the domain of f. And you could, again, you could graph this and you would be able to figure that out. Let's go ahead and write a rule. Now we've got something that looks a little different because we've got a square root going on there. But the way we do it is exactly the same. So we're going to take the function g of x, which is 2x minus 5, and we're going to put it in for x in here. So then I replace x with 2x minus 5, but I leave everything else the same. So let's get that out. So this could be defined to be that. Now I can simplify that a little bit, right? Negative 5 plus 7 is 2. So I could just say that's 2x plus 2. And again, this saves me some time when I have a whole list of numbers I need to work with. I don't have to do it over and over and over and over and over and over and over again. Now, what do we know? Here's where we have our restrictions. What do we know about this for the domain? We know this has to be positive. So 2x plus 2 has to be greater than or equal to 0. So 2x We subtract 2 from both sides, and then divide by 2, which makes sense, right? Because if I put -1 in here, I would get 0. And if I put 0 in here, I would get 2 square roots. But I can't take a square root of a negative number. So if it's any less than, if it's a -2 I put in here, then I would get a negative square root of a negative number, and that wouldn't be valid. So this would be my rule to make it all real numbers, except all real numbers where x is greater than or equal to -1. So you could say, you could do this, -1 infinity, right? You could do the set of all x's such that x is greater than or equal to -1. You could do that. Now let's look at this and see what it means. Again, this little circle, f of g of x, is the same thing as saying the f of the g of x. So I take g of x, which is 4 minus x, and I put it in for every x into my f of x equation. It has to go in for every single one. So now, instead of x squared, I'm going to take 4 minus x and square it. And instead of just adding the x, I'm going to add 4 minus x, and then I do add the 2. So that's the same thing. Now I want to expand this out a little bit. So this would be 16 minus 8x plus x squared. And since I'm adding, it doesn't matter what I do there. I can take away the parentheses. I'm going to look for all the things that are, okay, looks like my x squared's all by itself. I have a negative 8x and a negative x, so that's a negative 9x. And then I have a 16 and a 4 and a 2. 16 and 4 is 22. All right, that's my rule for my function here. Now, my composite function. What about the domain? Well, if I look at this, I know this is a quadratic, and the domain on the quadratic is always all real numbers. So it's negative infinity to positive infinity. All reals. All right. I want you to try, let me see. Yeah, go ahead and try the first one and the second one. I don't think there's anything, it's a little different because of the cubic, but you could figure it out. Let me get you started a little bit. So we're going to do both. We're going to do f of g of x and g of f of x, because sometimes the order does matter, right? We found that out. So if I do f of g of x, that means g of x becomes the input for this. So now I would have x plus 1 as my input, and I'm taking whatever my input is, and I'm cubing it. Okay, I remember a rule. That's the same thing as this. A times b plus 1. I remember that rule. And then I think I may just go ahead and, there is another way you can do this, but I might go ahead and just do the box on this, x squared, x and 1, and x and 1, multiply it out. And that's x squared, x, I should make my box a little bigger. So this is the same thing as x cubed plus 2x squared plus 2x plus 1. All right. So that's f of g of x. Now I want you to go ahead and do g of f of x, and it's probably not going to be the same thing. Go ahead and try that. I apologize, I got rid of that, so that's kind of annoying. That was x cubed right there. So that the output of f of x, which is x cubed, now becomes the input for g of x. So my input says I take whatever my output is, which is x cubed, and I add 1 to it. And I can't simplify that anymore, so I'm done. This other one is just a little extra. I think I'm going to go on. If you do want to try it, I'll write the answers here. F of g is x squared minus 10x plus 26, and g of f is x squared minus 4. Yeah. All right. All right, so here's something that our machines kind of do automatically when you're at different places buying different things, but it's important that you can figure out how it's doing it in case you need to figure out what your total is going to be before you get up to the counter. So this clothing store gives you $5 off your purchase, and then you can also use 10% off your next purchase. So which order should you ask for the discounts? And hopefully the machine gives you the best deal, but you know what? It may not. So you might want to just kind of double check for you to get the most discount. So let's call this first one, let's call the f of x to be, I take my price and I just subtract $5 from it, and that's how much it would cost. Let's take my next one, and I would take my price, which is x, and I would subtract 10%, because I'm getting 10% off of that. Remember to move the decimal over 2 places to the left. Well, that's the same thing as 0.9x, right? So I'm going to try 2 different ways. I'm going to have them take the 10% off first and then get $5 off that. That's what this one says. So the 0.9x is my output of my g of x. That becomes my input here. So the input, I take whatever my output was and I subtract 5 from it. So that one, I'm not doing any fancy math there. Now let's try the other way. Let's try g of f of x. So now I take my f of x, which is x minus 5, this one, and I replace it for the x. So x minus 5 goes here. Oh, well, I'm going to do it over here, make my life a little easier. I'm going to take 0.9 times x minus 5. I can do it there too, but I forgot I'd simplified it. So now I get 0.9x minus, that's 45 with that one decimal, minus 4.5. So which one gives me the better deal? This one right here. A whole section of 5.5. Adding and subtracting functions looks like this. Multiplying and dividing functions looks like this. And composing functions, making composite functions looks like this. So you need to be able to read and interpret what we're saying when we have these symbols that we're using. Here are the words that go with them, and here are some examples down here. It's very important that you're able to also find the domain of each of these. And again, you could graph a little bit to help you out. You could see from the graph if it's a situation where something can't be negative, or if it's under the, you have a square root of something, you know that you're limited on what those values can be too. All right, I'm trying to see if there's any other essential things that we should know and be able to do. I think we've done a lot of practice, so keep up the good work, and we'll catch you soon.